Okay, so in smaller classes, we have learned linear equations and how to solve the linear equation for one variable for the variable x. So let us look at solve 10x equals 3. So how do we solve this? We divide both the sides by 10. So we get x is equal to 3 by 10. And 3 by 10 is 0.3. So now we have learned how to convert a rational number to its decimal form or its decimal expansion. So this we saw in the previous video. All we have to do is we know how to divide and we know how to find the decimal expansion. So now let us see how to convert a decimal expansion to its rational number. For example, let's take the decimal number 0.3, and now we have to convert it to its rational form. So how do we do it? We have learned this in previous number. We write the number part as the numerator and we count how many digits are there after the decimal point. So one digit. So in the denominator we put 1, and since there is only one digit we put 1 0. So 3 by 10 is the rational number form or p by q form of 0.3. So let us do one more example. Convert 3.14567 to p by q form. So the first part is we write the number part as the numerator. So 31457, we write it as numerator. Now we count the number of places after the decimal point. 1 2 3 4 5. So there are 5 digits after the decimal point. So we put a 1 and then we put 5 zeros. Okay, so the p by q form of 3.14567 is 3,14,567 divided by 1 lakh. Okay, so first we write the number part as the numerator, then we put a 1, we count how many digits are there after the decimal point. 1 2 3 4 5. So we put 5 zeros. So we can convert a decimal number to its rational form or p by q form. Okay, so now we saw that rational numbers have decimal expansion that stop, and there are some rational numbers whose decimal expansion it keeps on going and repeating. For example, something like 3.333. So for the rational number 10 by 3. So how do we convert? Suppose we are given the number 3.333, and we want to convert this to its p by q form, that is 10 by 3. So we take x to be 3.333. So if we can get something like 3x equal to 10, we can get x is equal to 10 by 3. So our idea is to make this into something like this. Okay, so let us suppose x is 3.333. I think I forgot to mention one important point. Okay, so we saw that the decimal expansion of certain rational numbers keeps on repeating. So instead of writing 3.3333, we use the notation 3.3 and a line or a bar on top. So if suppose we had, so here this means only 3 is getting repeated. Another example would be uh, let us say 1.48 1.428571. So in this example we saw that these many numbers are getting repeated. So instead of writing this so much, we can represent it by putting a line on top like this. Okay, we call this a line, we can call it, it could be a line or a bar. So once we write it like that, it means we don't have to use this notation. This means 1.0.142857 is getting repeated again, 142857. So the bar represents that these digits are being repeated again and again. Okay, so let us come back to where we were. Okay, we were trying to solve rational numbers. Okay, um, so we have x is 3.3 bar, so which means x is 3.3333. Okay, so what we do is we want to get rid of uh, the repeating parts. Okay, so that is what is causing us a problem. So we don't want this repeating part in the decimal uh, portion. So what do? We multiply both sides by 10, so we get 10x is 33.33. We multiply by 10, so the decimal point shifts one place to the right, so we get 33.3333. So that is 33.33. So now we subtract the second equation from the first equation. So we first equation says 10x is 33.333, and the second equation says 10x is 3.333. First equation says x is 3.333. So now we have made the both the decimal parts as the repeating decimal portion, that is 3.33. So now if we subtract the repeating digits, that is 3333, this can be subtracted, and that will solve our problem, because the repeating digits is what makes calculation difficult. So now we have made the repeating digits same in both the equations. So now when we subtract, we get 9x is 30. So now it is easy for us, because if this repeating part is there, it is not it becomes very easy very difficult for us to calculate the answer. So we have 9x is equal to 30, so x is equal to 30 by 9. So again we can divide by 3, on the numerator and denominator we get 10 by 3, which is our answer. So the idea is we are trying to take away this repeating, we are trying to eliminate or put out this or make this part as 0 by subtracting it with another type of the repeating number. So what do? So if there is only one digit, we try to multiply it with 10. So now let us look at another example. Let's see, 1.27. So now we have two digits repeating. Okay, so therefore we multiply by 100. In the first case we had only one repeating digit, so it was enough for us to take 10x. Okay, now in the second case there are two repeating digits, so we take x to be 1.27 bar. Again, since there are two repeating digits, we take 100x as 1.27. So multiplying by 100, we get 127.2727. So we have 127.27 bar. So second equation we have 100x is 127.27 bar. First equation is x is 1.27 bar. So again we have made the digits in the after the decimal point as the repeating digits and the decimal point as same. So now if we subtract this part and this part will get cancelled away, they will get subtracted, and we'll get 99x is 126. So now this is easier for us to find our answer, because but if there is some this repeating digits here, then it is not we are not able to find our answer. So the idea is to make the repeating digits go away. And how do we do that? We multiply by suitable numbers to make them same in the first equation and second equation. Then we subtract them so that they get cancelled, and we get a linear equation in which there are no repeating digits in the decimal expansion. So we get x as 126 by 99. So if we divide by 9, which is the highest common factor, we get 14 by 11. So that is the rational number whose decimal expansion will give us 1.272727, and it goes. Okay. So another example is let's suppose x is 1.234 bar. So in this case, by what number should we multiply? We should multiply by 1000. So look at the number of digits, so and multiply by according. So if there are only two repeating digits, we multiply by 100. If there are 3 repeating digits, we multiply by 1000. If there are 4, we multiply by 10,000. So according to the number of repeating digits, we have to choose by what number we have to multiply. So if we look at here now, we have 1000x is 1234.234 और यहाँ भी 234 है. तो इस दोनों इन दोनों इक्वेशन को हम सब्ट्रैक्ट करें तो ये 234 और ये 234 जो रिपीट करता है वो आपस में कैंसिल हो जाएगा और हमें एक लीनियर इक्वेशन मिलेगा जिसमें the decimal part is 0 0. So then it is easier for us to calculate or arrive at an answer. So that is the idea. The idea is to take away or cancel out these repeating digits by multiplying with suitable numbers. Okay.